It's been about a couple of minutes after the hour here, so if anyone's running late and just joining us, we'll be catching up and we can get started now. So welcome everyone to the International Water Resources Association webinar on groundwater success stories, success in inventorying, measuring, and monitoring groundwater. So we thank everyone for joining us here today. Our panelists today include Kun Liu, a PhD and the Vice Director, Department of Water Quality Analysis and Evaluation at the China Institute of Geo-Environmental Monitoring at the China Geological Survey in China. Eric Everett, CEO of Homer LLC and a board member of the California Water Data Consortium in California in the United States, joining us quite early for him. And Jeffwanagwa, the coordinator of the Ministerial Task Force, Ministry of Agriculture, Irrigation, and Water Development in Malawi. So we're also moderated today by Anita Milman and Robert Kalin. So as you may know, this is a webinar hosted by the International Water Resources Association. The IWRA is an international network of researchers, practitioners who are all working on a multidisciplinary range of water resource issues. So we provide a global knowledge-based forum for bridging disciplines and geographies by connecting professionals, students, individuals, corporations, and institutions, everyone who's concerned with the sustainable use of the world's water resources. So this is a webinar as part of a series organized by the IWRA Groundwater Taskforce. And as you know, as I mentioned earlier, we'll be discussing the inventory and the measuring. As the old saying goes, you know, if you can't count it, you can't manage it. And I think that's something that we're going to be discussing in more depth today. I'll let Anita and Robert give a more detailed explanation of both the task force and the presentations. So let us just briefly explain the format of today's webinar. So to start, each of our panelists will give a short presentation, and then at the end of the event, we'll have time for questions from the audience. So if you have a question you'd like to ask, either for a single panelist or the group, please just go ahead and send it in. You should be able to see on the Zoom control panel at the bottom a question and answer box. So go ahead and post your questions there. And I've asked our panel to go ahead and keep an eye on that box. So if there's something simple they can answer, they'll try to get back to you as soon as possible. And if not, we'll have a time for a free discussion and questions at the event at the end of the presentations. So that should be quite good. And at the end of the event, as people always ask, we'll be having the presentations, PDFs, and a recording of the whole event on our website, www.iwra.org, within a few days. So just give us a few days and we'll get that put up. So with that in mind, I'd like to turn the floor over to our moderator, one of our moderators, Professor Anita Milman.
Great, terrific. Greetings and welcome. I'm so glad you are all able to join us here over Zoom. Today, I have the great pleasure of introducing the second webinar in the IWRA Groundwater Task Force's series on groundwater success stories. As many of you know, over the course of the next year, we aim to bring you stories not of the myriad groundwater problems around the world, but rather instances where progress is occurring. So we are talking about what we consider to be successes. The successes we are going to focus on take many forms, ranging from small steps that overcome barriers and facilitate future actions to broad achievements that have wide-reaching effects. So success does not mean that everything is perfect. Water is complex, and we can have successes in some aspects while still remaining an impasse in others. But even if not perfect, the success stories that we are going to tell have an important role in bringing about change. Success stories serve to generate awareness and help people envision possible futures. They also provide evidence that demonstrate that progress is indeed possible. And as such, success stories provide motivation. They can create a compelling narrative and help to move us past inertia. They're driving us to action, and they're helping to guide us, helping us to learn and generate new ideas and to grow. So today we're going to focus on successes in relation to a particularly important aspect of groundwater, that is that of knowing. The primary challenge of groundwater is that flows are hidden beneath the surface. And further, it can be accessed widely by many dispersed users. So these characteristics make it such that knowing in relation to having a clear picture of the state of the resource, of its withdrawal and its recharge can be quite challenging. But as Scott has said, knowing is an important ingredient for managing. So today we're going to focus on 3 examples of successes in relation to inventorying, measuring, monitoring, or otherwise assessing and estimating the use and status of the groundwater system. So in terms of agenda, we've got 3 amazing speakers for you, each of whom has firsthand experience with the success stories that they are going to present to you. I'm not going to introduce those speakers right now, but I want to talk to you briefly about the examples that our esteemed panel is going to present because they reflect diverse corners of the world, and consequently, each example has a unique approach to knowing, yet they all illustrate solutions to this common problem, that of a lack of data and information on groundwater. So our first example in China highlights the challenge of measuring water levels and water quality and communicating that information across a large geographic expanse, particularly when many areas of interest are quite remote. And the solution, so to speak, in this example involves some complicated advanced technology systems. Our second example in California highlights the problem of tracking and accounting for water use when measuring and monitoring needs to be performed across a multitude of entities and using a differing variety of methods. So here the solution is not centralization per se, but coordination and working with stakeholders and interests to develop mutually accommodating and accessible system. And finally, in our third example in Malawi highlights the potential for immense gains even when starting from a relatively blank state. So here the solution was a lot of boots on the ground, laying a framework and inventorying, and the outcome is an impressive depiction of the locations and status of water locations across the country. So all of these examples are worth examining and engaging in. They all include lessons learned and potential innovations that are transferable to other regions in the world. And I could say more, but I want to give the speakers the opportunity to convey that information to you, and then for you to ask your questions of them. So with no further ado, I'd like to pass the microphone to my colleague, Bob Kalin, who's going to introduce each speaker.
Well, thank you very much, Anita. That was an excellent introduction to today. First of all, I'd like to say ni hao. We are going to have Dr. Liu Kun speaking on the China National Groundwater Monitoring Project. Dr. Kun graduated from the University of Hong Kong in 2014 in hydrogeology with a PhD. He currently works at the China Institute of Geo-Environment Monitoring within the Ministry of Natural Resources. And he's a founding member and major operator of this Chinese National Groundwater Monitoring Project. He's also now the vice director of his department in charge of the groundwater quality analysis and evaluation in China. So the success story we'll be looking at the project completed in 2019, which included over 10,000 monitoring locations that collect and transmit real-time data on underground water levels, temperature, and water quality. With this, I really thank Dr. Kun for coming along and speaking. Please make your presentation.
Okay, can you hear me? Yeah, I'm Liu Kun from China. Thanks the IWRA and thank you all. It's my great honor to be here, and I'm very glad to show you the China's groundwater monitoring project. Now, can I share my slide?
Yes, please.
Okay. Yeah, per minute. Okay.
There you go, looks great.
Let me begin. So this is the topic of my today, the Chinese National Groundwater Monitoring Project. I will show you the construction, operation, and outcomes of it. On behalf of the China Geology Survey, I cannot say the ministry. Okay, let me see what's next. Here's the outline of my topic today. First, I'll give you a general instruction of the project. The National Groundwater Monitoring Project is an infrastructure project approved by the National Development and Reform Commission and directly invested by the central government and constructed by the Ministry of Water Resources and the Ministry of Natural Resources jointly. The NDRC is a very powerful party in China, in charge of all the major investment projects in China. And the Ministry of Water Resources is in charge of the admission and management of water in China. And the Ministry of Natural Resources, formerly called the Ministry of Geology and Mineral Resources, is in charge of the resources underground. So how about the water underground, the groundwater? Then it brings two questions. First, what's the groundwater monitoring situation in China prior to this project? And China's groundwater monitoring began from the 1950s, was mainly carried out by these two ministries. About 2,000 to 3,000 groundwater monitoring stations were specialized, designed and used to monitor the groundwater levels continuously on days or weeks basis. The data was sent to career authorities for analysis or scholars for research. Till the year of 2000, the development of groundwater monitoring in China is much slower than other businesses, leading to several problems, including insufficient number, inappropriate distribution, and the monitoring contents are quite limited, just the groundwater levels, temperature, or just the major ions. And the techniques was very slow, especially some provincial institute stopped this work because of the insufficient funds. So the hydrologists and the experts in China draw a conclusion on this. China needs a whole new system of groundwater monitoring. Then in the year of 2004, the Ministry of Geology and Mineral Resources submitted the proposal named National Groundwater Monitoring Project proposal to the NDRC. And 2 years later, the Ministry of Water Resources submitted a very similar proposal to the NDRC too. And after 2 years later, the NDRC said, you both ministry can do this job together. And we agreed to prepare one proposal on the basis, the principle of one project, separated implementation and information sharing. And after many years, in 2014, the NDRC finally gave us the fund of 2.3 billion RMB to start the construction. And after 5 years hard work in 2019, it's finally complete. So first, the major part of it is the stations. We have built more than 20,000 professional groundwater monitoring stations in whole China, which significantly enlarged the monitoring areas. And during the construction, the hydrogeological parameters were collected and renewed from drilling and pumping tests during it. And according to different structure of the geology, we have different types of stations, such as single wells, group wells, CMT wells, etc. And every well have an automatic monitoring instrument to record the temperature and the water level. And after installation, it is calibrated regularly to ensure the accuracy. And in some very remote area, we use Beidou satellite to send the signals to conquer the weakness of the GMS. We also reconstructed 2 groundwater comprehensive monitoring sites in Xinjiang and Zhengzhou separately to do the groundwater research. We also have repaired a sea level monitoring station in Qinhuangdao, northern China. And with gathering all this, a lot of amount of information, how we can use it, analyze it, and serve to the public, we build a modern information application service system, including a platform, a database, 3 subsystems, and apps for both professionals and publics. All the principal provincial information nodes were connected to the national center, where I'm standing in. And we have a backup center in Guizhou province in case the national center breaks down. Okay. Using the funds, we also, this is the national center. We have 2 floors, especially for the water quality testing and control lab. 1 floor for organic test and another floor for inorganic test. Here are some pictures of the instrument. And finally, after finishing this work and running test for nearly a year, at the end of the 2019, the meeting of acceptance inspection for this project on my side was held in Beijing. And the group is very strong, 14 experts, including 7 academicians in China, all in geology, hydrogeology, and other aspects. They have all agreed that the completion of this project was a landmark achievement and lead China's groundwater monitoring level into world class. So when it's done, how it runs, and the second part is operation and maintenance. We have maintenance of the monitoring site. When it's broken, we repair it or reconstruct the wells, and maintenance of the equipment and to calibrate it or download the data inside it when it's broken. And the operation of the comprehensive monitoring site, the maintain and upgrade of the information, and a very large part of the annual year job is to collect the groundwater sample from all the stations and send it to laboratories for chemical test and get a knowing of Chinese groundwater quality. The full question is, after it have run 3 years, what's the achievement? First, we have a general understanding of the national groundwater levels and the changing rates, shallow part or deep part, and the groundwater level changes in not only the northern China plan, but other major plan in China. And then the national groundwater quality conditions and annual changes, including geochemical types, the water quality assessment based on standards, and the concentration of chemicals, for example, the bromine and other kinds. So the last part is how the work can be done in China and what's the good experience. And first, here is China. China rules from the top to the bottom. So if you want to do something right, done something, you must have great support from the government. We can grant great support from the ministries and the China Geology Survey and all the provincial departments. We have a lot of meetings and send a lot of red title papers, which means authority. And we have careful planning and organization for this project. Before it begins, the construction begins, we have 2 years for planning and organization and promotion. And during the construction and operation, we have overall process quality control and inspection from all the aspects. And the most important part of it is that at this time, we have sufficient funding support. It is about 130 million RMB every year to do the running, the operation, the maintenance, the research, and the supporting job. Thanks to the Chinese government, I have my salary for this. That's all. Thank you very much.
So, Sheshe, thank you very much. So today we are going to hear all 3 of the talks before we go into the question and answer session. So it's my, I'm very pleased to be able to next introduce Mr. Eric Everett speaking on the California Water Data's Consortium Groundwater Pilot Project. Eric is the CEO of Homer LLC, a company which has developed an unparalleled network of water sourcing, storage, distribution assets to sustainably supply water to California's Central Valley farmers. So he's worked in the industry for about 30 years, the last 20 of which as a general manager of 2 water districts within the Kern County. And he's been working on finding solutions to water quality and supply reliability challenges faced by these water uses, both domestic and agricultural users. What he's going to be speaking about today is a path to decisions informed by data, California's Water Data Consortium Groundwater Pilot Project. In California, a significant amount of data is collected and retained by the state's regulatory and local water agencies. And the California Water Data Consortium is working with a variety of interests, seeking ways to make sure that this data is more readily available to stakeholders and to decision makers to inform decisions regarding regulatory policy and overall water management with the state. And with this, I'd like to introduce Eric and look forward to your talk as well. Thank you.
Thank you very much for the introduction, and I appreciated the prior presentation. I lean more towards the technical and the practical, but find myself more and more dragged into the policy arena, especially when we're talking about groundwater. I thought, I don't have a prepared presentation. I thought I would expose you to a stream of consciousness that kind of meanders around some of the issues and challenges that we have here in California regarding what I call informed policy decisions. And so to set the stage for that, I'd like to maybe tell a little story. Water districts throughout California collect lots and lots of data. In fact, very early in my career, I would go out into the field and measure wells, and each well had a sticker on the power pole or on the power box, and it would identify all the people who had gone to measure that well. And I was always confused why there were so many people measuring the same well, sometimes just weeks apart. And so you'd have the Department of Water Resources, the State Water Resources Control Board, the Kern Water Quality Coalition, all of these entities would go to this well and measure it. And so if you took a calendar year, you'd have like 15 measurements of the same well. And it wasn't like they were spaced in an interval, and there wasn't any coordination with that. So as my career advanced and I got involved in politics and the drafting of regulation, I asked a question in a meeting one time. I said, can somebody explain to me why this new regulation that we just got is asking for measurements of water depths when you've already got all of that data? And they said, well, but this is our department. We don't know what everyone else is doing, and this is our regulation. And I said, okay, we've got to stop this. So fast forward to about 2017, and California, in their infinite wisdom, passed a bill called AB 1755, the Open and Transparent Water Data Act. And it was a very important piece of legislation because for the first time, what it did is it said, look, we need to get information not only into the hands of regulators who make decisions, but we need to get it into the hands of people who are managing water or who are interested in water, whether they be from an academic or an environmental justice. And so for the first time, California comprehensively said, we've got a lot of data, but it's all kind of archived. And I don't know if you remember the movie Raiders of the Lost Ark, but the very last scene, you know, they take the Ark and they put it into this giant warehouse, never to be seen again. And that's what happens to a lot of the water data that's collected in California. It's archived, and then it's kind of hidden away, and it's not used to inform decisions. And so AB 1755 formed the Water Data Consortium, which I'm a board member on. And our job in the consortium is to kind of bridge that gap and start to look for opportunities, especially amongst water districts and water agencies that regulate water, to centralize the reporting of data. So I'll touch on the pilot project in just a minute, but I wanted to touch on what I call data utopia. Data utopia is this vision that I have in my head where all data is collected and delivered or uploaded to this centralized repository where then anybody and everybody can access it. Now, there may be reasons why some data shouldn't be accessed and some data should be retained in privacy concerns, but you can create those filters based on some user access levels and those types of things. But we really need to move in that direction towards data utopia, where we eliminate redundancies, both in collections but also reporting requirements. And to give an example, the water district that I managed before I came to my new position, I put a table together of how many different regulatory reports requested water level data. Different agencies, all under the umbrella of the state of California, 17 different reports. And sometimes I had to hire different consultants and they would have to go out and collect the data because they wanted it at this location or this month. But the point is that it's still water level or water elevation data that ultimately, if the state would say, and this is my version of data utopia, we need water level data. We've looked at all the regulatory programs and we need water level data monthly, and we need it at these locations from these types of wells at these screened intervals. And we'll use that data to inform not only the existing regulatory paradigm, but all regulatory paradigms. Then that's much easier than having 17 different regulations with 17 different reporting requirements, and each of them requiring me to hire a consultant to prepare and upload. So Data Utopia is kind of this vision of a very centralized data platform that all water districts who collect this information upload to the cloud or to some centralized repository where it can be shared with all users. So let me fast forward and touch on the pilot project that we're working on. The pilot project is really bringing the regulatory agencies that very often are what I call siloed. And that means that, for example, the State Water Resources Control Board is an organization in the state of California that has a very specific mandate. And they draft and implement and enforce regulations that are consistent with that mandate. They have no clue, literally within the same organization, what the next regulation is. One regulation may be governing nitrates in groundwater, and the other regulation may govern what we call the dairy order, which is kind of maybe it's arsenic, but two within the same organization, two different regulatory paradigms, each with their own staff, having no clue what the other is collecting, but they're each collecting the same data set. And so the pilot project that we're advancing is to break down those silos and get those regulatory agencies to kind of cross-train, cross-pollinate each other and look beyond the scope that they're currently looking at and see this broader picture, which then will create some efficiencies both with the data reporting, but also data dissemination. Much more powerful regulations and policy decisions can be made when there's a single data set. Now, I want to talk a little bit about that. There is no standard method for collecting water level data. And so when you have a lack of standardization, the quality, the QC of the data is questionable. And you really struggle with, can I rely on this data to inform decisions? And so part of Data Utopia, part of the pilot project, is to get these regulatory agencies to standardize. And it doesn't mean there has to be just one method. It just means that there has to be a list of acceptable methods to collect water elevation data. Are you using what we call NAD 27 or NAD 93? What's your reference point? Is it ground surface elevation? Is it mean sea level? All of these things, because right now, in the absence of standard, you get just a jumble of information. So the pilot project that we're working on and advancing is to break down the silos, standardize the data sets, basically centralize the reporting requirements, let the state agencies come in and query the data along with the water users for their regulatory programs, and then broaden the scope of who can access the data. And that's very, very important. What we found is that data can be a very powerful tool and can also be a club. And giving data to a broad list of users is very effective in informing not just policy, but the decisions that water users make with respect to managing the resource. And so with that, I'll go ahead and conclude, and I look forward to the question and answer period of the discussion.
Well, thank you very much, Eric. That was a really interesting walkthrough your Data Utopia ideas, and I'm sure it'll provide lots of food for thought as we move into the discussion section. The final talk of today's webinar before we move into the Q&A session is by Jeffwanagwa, speaking on Malawi's MWater Taskforce and the groundwater and water point inventory that was undertaken there. Jift is a senior groundwater development officer with the Malawi government Ministry of Forestry and Natural Resources. He's stationed at the headquarters in Malawi's capital city, Lilongwe. His duties are mainly hydrogeological, including geophysical surveys, supervising drilling projects for water sector partners and for the government, research in groundwater development and management, and hydrogeological data collection. He's coordinator of the Ministerial Task Force on MWater and a member of the International Association of Hydrogeologists, as well as his work with the IWRA. He has worked on many groundwater projects in the country with consultants and non-governmental organizations like Water for People, the University of Strathclyde, Habitat for Humanity, Well Hunt Finger, World Vision International, just to mention a few. He's graduated with a master's in water resources and supply management from the University of Malawi, the Polytechnic. His success story today on the MWater Management Information System and inventorying the supply assets across Malawi is around, again, 2019. Malawi completed mapping and assessing over 124,000 rural and peri-urban water points across the country. The end result is the first national scale audit of every water point in the country and the assessment of its current condition. The data is stored in MWater Management Information System and includes information like the water resource, the funding agency, functionality, water quality, and a survey of wellhead protection risks. With this, I'd like to introduce Jift and welcome your talk. Thank you very much.
Thank you very much, Bob. Let me just upload my slide. I hope. Okay. Okay, good afternoon. Okay, thank you very much. Good afternoon, everyone. I am Jeffwanagwa from the Water Resources Department in the Ministry of Forestry and Natural Resources. And I will be presenting on our groundwater success story in asset management in the country. We at the Ministry of Forestry and Natural Resources, we believe we can manage what we can measure. And we would wish to be bold enough to manage groundwater with the data that is available, that is accurate, and that is validated, reliable, and relevant to our work. So our decision makers, planners, regulatory authorities, bodies, risk managers, and operational managers should make decisions with the data that we have collected. Malawi is a country in sub-Saharan Africa and has a population of about 18 million people, and 85% of these rely on groundwater for their water needs. And to that effect, at least you can appreciate the huge task of managing groundwater in the country. But as is the case, the groundwater management in the country has had a lot of challenges that has been faced. And the first one is the lack of data or enough data or incomplete data that we have with plenty of inconsistencies as well as gaps. And sometimes the data also lacks some very important bits of information. And we also have the problem of vandalism of water supply and groundwater monitoring infrastructure and many other challenges that we are facing. For example, shortage of groundwater personnel in hydrogeology to maybe make informed or qualified decisions. And then there's also a shortage of equipment. For example, transport is an issue. Tools for data collection or groundwater data collection is a problem. But we have groundwater monitoring stations, and we have also water supply structures or infrastructure in the country where, as I have said, 85% of people rely on groundwater. So we have pumps and we have boreholes, we have shallow wells, and we have both improved and non-improved water sources. So the success story that we are about to talk about today, or we are about to share with you, is a success story of achieving the mapping of our water points so that we know where they are, in what condition they are, and what the problems are with our water supply. So we did the water point mapping, and we created an inventory, and we are able to monitor and measure the status and their operation as we use them. So this success story is also the moving from data that was stored in paper form to data that is digital, that can be accessed from anywhere in the country, and at any time when somebody maybe needs requires the data to use, and maybe makes a request, so you can just go online and then log in and check the data and provide at the same spot when the data is required. The activity itself was funded, was implemented under the Climate Justice Fund Water Futures Program. That is the Scottish government, and it was an initiative where the Scottish government was working towards helping the Malawi government achieve the Sustainable Development Goal number 6. The work itself was done in partnership with the Malawi government and WASH partners in the country, and funded by the Scottish government, as already sort of said. So data was collected using the inertia app, which is a free app platform and uses Android phones to capture data digitally to the cloud. So you have an Android phone, and that Android phone has been installed with the inertia app, and then you use the inertia app to do the data collection, whereby you have a survey in it, and you just sort of ask the questions along with the survey, and then record the answers that are there, and then you just click and then submit the data, and then it goes to the cloud for analysis and approval, so that it is good, reliable, and valid. So the data itself was collected by district councils, where we used the extension workers at the district council to go into the field and map each and every water point, whether improved or unimproved, and any type, whether it is a borehole, a shallow well, a tap, or just a hand-dug well. And after collecting all that data, the extension workers were submitting the data online using the Android phones, and then the data was analyzed and checked by the officials who were responsible to approve, for example, the Groundwater Taskforce, as well as the partners. And after approving through several stages, the data was certified to be okay and would be used for planning, as well as all the other requirements that people might want to use the data for example, in the implementation of interventions against COVID-19 and other issues that are on the ground in the country. So the data that was being collected was water point data, but it was cross-sectoral. It covered many areas, for example, sanitation as well as water. It included data on water points, for example, maps which show where the boreholes are and in what condition they are, as depicted by the colors in the maps. In the maps, you can see the dots, and those dots represent the type of water points, and in some cases, they represent the condition of the water point. And when you click on a dot, it sort of comes up to show all the data about that water point, whether it is functional or it is not functional. And if it is not functional, it also shows what the problem is at that current time, because the data is real time. Also, the data can also, when you click a dot, it also shows many different types about the water point, or maybe different types of data about the water point. For example, that one is in series of water point or borehole, and then you have all the data in terms of the conditions, the number of people who use the water point, and every other details that might be required. For example, who funded the work and when was it done, and everything else, the type of pumping device that is installed there, and many other details as shown in the next slide. So you have all that, and that is mostly water point functionality survey data. And we collect all that data for every water point that we have recorded. And the management information system also has data on several other groundwater resources. For example, we did borehole forensics data, and all that data is there. For example, they use the borehole, the lithology of the boreholes, the geological data of the water points that we have. But the whole work that we have done, we have also had some challenges. For example, the ones listed there. For example, we have not covered all 100% of the country because some areas were hard to reach, and then they needed maybe more preparations to go to those areas to collect the data. The other one is maybe sometimes we had internet connection problems whereby somebody goes and then when doing the water point mapping or maybe when collecting the data, because you have to submit the data and then when there's no internet, sometimes you have problems whereby you do maybe several water points and all that data is kept to be relayed later on. And sometimes you miss out on that data maybe going through and then you have to redo it. And sometimes we also have problems with the gadgets that we were using to do the water point mapping. Another thing that we also had a problem with is the only funder to this initiative was the Scottish government. So we are just sort of maybe, since we haven't covered it 100%, we still need time, but then we are not very sure if the Scottish government will still have the same policy to assist us in asset management, or maybe we'll move on to another maybe area of focus, for example, regulation or other areas. So if that is the case, then we will need somebody else or some donor or some stakeholder to assist us, maybe to take up the activity so that we reach the 100% mark. So the way forward is that we would wish to have more stakeholders that are required to support and engage with the effort of asset management and water resources monitoring. We have stakeholders, we have partners, but most of them have been more into development of groundwater to supply water to the people and not necessarily in asset management or water resources monitoring. So we have groundwater monitoring networks, but we still need some more, and we can sort of use some assistance to that. We also look forward maybe to the academia to also introduce more groundwater explicit curriculum, whereby as of now we have water courses, but most of them are focused more on surface water resources. So we will also need that, but then also we would wish to have coordination between stakeholders, whereby we don't duplicate activities or we do everything together, because all the activities that are being done for Malawi. So we would wish that maybe there should be more coordination, more interaction between the partners, so that at the end of the day, we are doing a work that we do together, and all that effort can be put together so that maybe we work strong. That marks the end of my presentation. Thank you very much for your kind attention.
Well, if I can ask everyone to put our virtual hands together for thanking the three speakers for their talks. I think the IWRA Groundwater Taskforce has done an excellent job of bringing together three talks from three different corners of the world. I suppose you can have a corner in a round world. But what we see here is all of them are challenged with the same problem, that decisions have to be made. They have to be made within a regulatory framework. They have to be made within a political framework, within a control of a budget. So there's a budgetary constraint for these decisions as well. And data is the key thing that allows people to actually make robust decisions. And I think all three of the talks have focused back on this one specific issue. And I would like to personally thank all three of the speakers for very interesting presentations on the ways that you've been trying to meet those challenges. I think we can now move into a Q&A session. I believe we have about 45 minutes for a Q&A session here. And I'll hand over to Anita, and please remember that there's a Q&A box. You're welcome to type in your questions there, and then we'll pass those over to the speakers. I think the Q&A box is probably easier than the chat function, but we'll also look at the chat box just in case you have challenges with it, with the Q&A box as well. But please start typing your questions in there, and we'll be posing those to the three speakers. So Anita, if you could, I'll pass it over to you first.
Great, terrific. Thank all three of you for wonderful presentations. The first question that I have for you is one related to the role of water users in this process. So in both the California and the Malawi examples, you mentioned that either water users was the ones that were collecting the data, or they were reporting with the data to state regulatory agencies, or they were more of their input was needed in order to do the inventory and collection. And I'm just wondering how you got their buy-in and support and how you work with the water users to get them to be involved in the data collection process. And then Kun, for you, I'm wondering what role does China see for involving water users in this monitoring project in the future?
So maybe I'll start and then turn it over to Gift. The way we created incentives is to create those efficiencies where ultimately those 17 reports that I gave in my example are consolidated into one. And so there's some cost savings and certainly some economic incentives that will help drive that kind of more efficient data utopia model that I described. The other one is water users also need information to make decisions. And so by way of example, as a water district manager, I wanted to know not just what the groundwater level was in my district, but what it was in the other district. And I didn't want to have to request the information from them because I would usually get it, depending on how cooperative they were, in a box with just a whole bunch of papers if they didn't like me, or sometimes I'd get it on a spreadsheet if they did. But it's really just quick and easy access to information, because if I'm seeing water levels decline in part of my district, I want to know, is it because the other district is pumping more water out and lowering their levels and creating this decline or pumping depression? So the incentive is to get data to inform decisions that the water users are making on their own, and then the other one is the economics.
Oh, thank you. Maybe I can also come on the data collected by users. In Malawi, we have a system whereby every water point has got a water point committee. And this water point committee is made up of 10 people. Preferably, we recommend to have 6 women because of the importance they have, maybe the connection to water as well. And then 4 men. So we have a chairperson, and then we have a vice, and then we have a treasurer to be collecting money for operation and maintenance, as well as a secretary who records everything. So these people are those who have been in the area for a long time. And sometimes even when you go to develop or to drill a borehole, they are always having information about their areas. Say maybe these areas are like this. Maybe you might hit a dry hole there, but you might drill maybe a good hole, maybe this other state, or there are issues of salinity or not. And then they are the same people which we target in order to answer the questions that are there in the questionnaire. In most cases, the questions are focused on mostly, for example, functionality. You ask maybe, when do you open the borehole? How many people use the borehole? How much do you contribute? And then we also, as the technicians, we do the pump test to check the yields, where we time it with a clock, and that information is there in the system. It can do the yield test. You just click on, and then it calculates, and then it will tell you maybe the yield is like this. So we record it like that. But in most cases, whatever information we want, we always ask the users, who are the committee, and sometimes the chief or the leader of the village, and they always provide information that we want, except maybe more technical details. That's where we might come in as a department, because we have some literature, we have the profession, and then we have also the expertise that maybe we know most of the things. But the users have always been instrumental in explaining everything that we want. Thank you.
Kun? You're muted.
You're muted there.
You're still
Kun,
muted.
you're muted. Can't hear anything.
Okay.
There you go.
Okay, can you hear me? Sorry.
Wonderful. Start from the beginning.
So which question? I have a lot of questions here.
Oh, we were
Which one should I
asking,
answer?
what role does the China National Monitoring Project see for water users in helping with the data collection in the future, if at all?
That means how to use the information for the
people that own or use the wells, what role do they have in collecting and monitoring? And is there a role for them, or will that be expanded in the future?
Okay, the owner of the stations is the country. We own it, not any person, not any company. The government give the money to build the station. So we hire local people to watch the station for us. Every year we pay like 1,000 or 2,000 RMB. But the the station and the data belong to the government. And if anyone wants to use the data, they have to sign a lot of papers to ask for the numbers and assessment results.
Well, thank you, Liu. And in fact, that leads us into another question, sort of based on a number of those that are coming through in the question and answer box. Because this access to the data is, every country I've worked in, it's always been one of the big challenges.
Yes.
Researchers always want every piece of raw data and the smallest minutiae little piece. A decision maker wants 4 million pieces of data into one paragraph so they can make a decision.
Yes.
And so the question always is raised about how much of the data and in what form should it be in the public availability, and how much of it needs to have some kind of interpretation and cost associated with it. So we'll start with you, Mr. Liu, and then we'll go back to Jift and then back to Eric, because I think it would be interesting to see what each of you have to say about that interesting question, which has been posed by a number of our attendees.
Yeah. First of all, the groundwater information, the data is free for money. You don't have to pay anything to gain it, to get access to it in China. If you are a member, a part of the government, the China high school or institute, you just have to apply for it using our procedure and our information servicing system. But I think it is a little bit different, a little bit difficult to share to the world, especially the part of the groundwater quality. And someone in the government said it is very sensitive. I don't know why it's sensitive. It is paid by the government and it should be shared for the people. But someone thinks it's sensitive, so it's kind of classified. I can say it, my department can say it, but not everyone is able to allow to say it. I think that's the problem. But if you really want to use this data, use this very precise result, I think the better way is to cooperate with the Chinese school or Chinese institute, and they have means to gain this data, and then it can be published and the world can have it. That's the easy way.
Yeah, thank you very much, Liu. Jift, your thoughts from Malawi, please.
With Malawi, the data that we have, the water resources data belongs to the National Water Resources Authority. But there is accessibility by many or anyone for the data, as long as they explain what the data they want and for what purpose they want the data. For example, functionality data is offered for free, where the data itself will talk of the locality of the bore or the water point, the condition of the water point with the coordinates and every other detail, for example, traditional authority, the area in which it is, and maybe the problem that is at hand for that bore. If it is functional, it will explain that it is functional, and we also still share maybe the need for the data is for use for other purposes. But when somebody wants maybe specialized data or bespoke data, that is the data that maybe might attract a cost, not necessarily as if in selling, but for cost recovery. As we said that the only funder that we had was the Scottish government. So for us to do updating of the data, for us to carry on collecting data, because more and more water points are being developed and we need to collect data for those, and maybe to have the right equipment, as I said, we need some resources to do it for ourselves. So that is where we can charge a small fee or just for cost recovery, so that the process or maybe the initiative is carried forward and we have the data that maybe to the extent that we want it to be. So in terms of accessibility, for example, for informative data, the data is open online on MASDAP. That is the Malawi portal for development, maybe information, where people can access data on water points, as we say, for example, maybe on geology and many other data, for example, education and other data that maybe is used by the country. So we also have posted on the same so that people should have access to it. If they have any question, they have seen something and they want to ask about that type of data, they can always contact me. I'm the coordinator of the IWRA Taskforce. So we can link the person to the right sort of maybe or the data that they want. The IWRA Taskforce is made up with people from all the departments in the all divisions in the department. For example, we have groundwater people, we have surface water people, we have water quality people, as well as planners in the ministry. So every request, we'll look at those things and then we'll sort of maybe discuss to say, there is this request for this type of data, and what do? We consult with the National Water Resources Authority, and then we issue if it is for free, and then if there are anything to be discussed, we discuss with the one who made the request, and we provide the data, or maybe we guide accordingly. Thank you.
Well, thank you very much, Jeff. And moving on to Eric, I mean, you made a point that sometimes these things are in paper form in a box somewhere, and someone's ultimately has to type that in. Now, we may think that those people will be altruistic and work for free for their entire life typing all that data in, but we know that's probably not the case. And a number of the questions that have been following on are talking about the minimum requirements in terms of setting up something like this. Perhaps maybe you could describe a little bit of the terms that were required to get that data into use.
You know, excellent question. And we're actually in California, kind of right on the cusp of consolidating a lot of our data into these data management systems. And so there was a package of bills that were passed that mandate annual reports, but also historic groundwater models be developed. And ultimately, these are going to be paid for by the water users. And so what I mean by that is, as a water district manager, I had rates and I had the ability to assess my customers in order to not just provide water, but to comply with all the regulatory requirements that governed water. And so with Sigma, we will finally be putting together, based on a hydrologic region, a data management system that will be used to collect and then ultimately disseminate data to individual users, whether they be regulatory agencies or landowners. And so that system is actually just now getting, we're getting proposals for that system, but ultimately the idea is that it will be made publicly available. So when a public agency in California collects information, by virtue of it being public, or a public agency, you lose the ability to limit public access to it. And so what I mean by that is, as a public agency, anything that I discussed or anything that was within my files, if you will, could be requested and had to be disclosed to the public, unless it was a function of litigation or something like that. So water quality, water levels, water supplies, all of those things are available to the public. Now we're getting to the point where we can make it easily accessible, as opposed to having to come into my office and walk out with a box of copied papers. So.
Great, terrific, very interesting. So now that we've talked a little bit about how the data is available and who it's accessible to, I'm curious about how all three of you see this data being used. So now in California, we've heard that this data is much of it is being created and collected as part of a regulatory process. Whereas in Malawi and in China, the government is collecting this data itself for their own purposes. But what is, now that we have the data, or the data will be centralized, what is it going to be used for? How will it inform or guide management decisions?
So I'm still off mute, so I'll start. You know, in the ways that it should, frankly. We have academic institutions that will use the data to evaluate long-term trends. And, you know, for example, we have a university that's looking at, you know, are we putting too much total dissolved solids into the soil as a result of imported water supplies? So we have environmental justice organizations that need the data to track water quality and whether or not it's going to impair certain groundwater wells within regions that maybe people can't afford to apply treatment. It's going to inform, as I've been talking about since we've had this discussion, regulatory decisions. It's going to inform decisions on where I should put water, where I need more water, those types of things. And so, you know, data informs decisions, and I think there's no finite limit to the decision that it can influence or make a better. So, you know, we're very encouraged by that, and we see it as a positive trend.
Liu,
Yeah,
what are your thoughts on that question?
the question of
How will China use the information to inform management decisions? What is it going to do with the data from the monitoring networks?
basically we get the information monthly, and we start to write reports on month basis, quarter basis, half-year basis, and year job, the annual report, and send it to the government before the big meeting in spring. And then at the middle of the next year, it will be open to the public in China. So I think that's how they use the information.
Jift?
Yes, thank you. Within Malawi, we have many uses for the data. And especially now that we have it, we know a lot of things that maybe we did not know at first. And now we are in the know and we can go in the right direction. For example, we have districts which prepare investment plans. These are plans of what they want to do in the wash sector. So they want to know how much they might require or what they should do. So they are referring to the data that is in M-Water. For example, how many boreholes do we have? Should we do some more? What is the situation with all these boreholes? Are they functioning properly? Should we change? And then in terms of also looking at who drilled these boreholes, who is the funder or who was the funder? These boreholes drilled by this certain contractor, how are they faring in terms of looking at maybe the functionality, and then you look at which boreholes are not functional, who drilled them. So if you go back like that, you can tell maybe that this driller was not doing a good job because in every place, his boreholes are not functioning properly. And then with maybe another driller, you find that maybe the boreholes drilled by a certain one, you find that they are always maybe functioning properly for a long period of time. And to some extent, looking at also the problems, you can easily tell to say, in this village or in this area, there is this borehole functioning like this, in another area, there's this borehole functioning like this. And you also compare the problems that the people or the communities are facing. And this data has also helped in allocation of boreholes, because you find that maybe sometimes allocation of boreholes goes without consideration for certain factors. You find that you have boreholes in one area, and this has been shown with the maps. From the mapping where we do the coordinates, we don't sort of maybe place them anyhow, but we do the coordinates of the boreholes where they are. And you find that the boreholes are concentrated in only one area and another area is lacking. So now the officials at the district can always explain to anyone who comes. For example, maybe a stakeholder comes and then says, we would wish to assist you with 5 boreholes. Where do you want them to be? Somebody goes straight to M-Water, checks the map, and looks at communities with problems, and then also looks at communities which desperately need the water, and the allocation is done. And then also, when it comes to repairs, you can also look at what was the problem in this borehole or maybe the other borehole, and you find that maybe there are several parts which are always the problem. They can also inform the designers or maybe the manufacturer to say, your boreholes or your type of technology has got this element, which is always a problem in every way. And the government can also go in to sort of maybe encourage maybe business people or other maybe stakeholders to say, maybe we have a problem in this area and we need assistance. And also we have always had some research students at the universities. Now that we have water courses that have been introduced in the country, and you find that they are looking for data. So the government is also on the ready to issue data to those people so that they can do their research and can understand whatever they want to understand from the data that is provided. We also have joint sector review meetings where all stakeholders in the WASH meet and discuss the status of the water points and maybe the WASH sector. So this one explains and that one explains, but you know, data can provide another perspective. So you find that people are reporting, giving all the details and showing what is on the ground from the database so that all the participants understand and appreciate what the problem is. And also, we also have some stakeholders who are bringing in some interventions, and maybe they want to bring in a new intervention. And when they come, they would wish to know how many boreholes we have in this area or in that area and what the problems are. So we are able now, because we have the data, we know what is on the ground, we can explain to them. Maybe they come to drill boreholes, we can advise them that we have enough boreholes in this area, but we have this problem. Could you please maybe shift the resources to assist us in this area? And they have always been doing. So we have always been on the answering side and providing the data that was required, especially during the COVID-19 situation where we wanted to know how many boreholes are supposed to be given. And we have been providing data to many interventions or maybe many stakeholders, and they have been using the data effectively to sort of maybe respond to all the needs that were there. Thank you very much.
Thank you, Jeff. That was very helpful. There's a number of questions that are in the same theme that have been coming through. Like, you know, what is the minimum requirements of the number of sites or the types of monitoring that you would do? Or how often should you do it? Should it be on a monthly basis or a yearly basis, or for groundwater level on a minute basis? So there's quite a bit of questions that are coming through about this, the amount of data that we actually need. And I'd like to reflect a little bit, because I actually live in Scotland right now, not far from Glasgow, and we have COP coming up to look at the climate change issues. And one of the biggest challenges I think we face is, when is enough data for a decision to be made? Now, you can see I'm a little bit older than I think most of you, and when I started writing papers and reports, a graph was on graph paper with a pencil and a ruler, putting in a few dots, where nowadays I can download a logger with 40,000 pieces of information for the last 2 months, and then just have that automatically graphed up even on the screen for me without ever having to type a single number in. So in both those conditions, say, you know, maybe in the 1970s or now, decision makers have to make decisions based on the data that's there and the interpretation of that data. And I think from a lot of the questions is, how much data do we really need for decision makers to make a decision? And maybe I'll start with Eric, and then we'll go to Liu, and then we'll finish with Gift on this one. Thank you very much.
You know, that's the age-old question, and in some ways the reason why we see some regulatory programs looking for data or information on one schedule or at one interval, and others looking for it at another, because truly, you know, each constituent, each decision may require a different level of granularity. And so what we have to do is, this is again part of my data utopia, as that granularity becomes tighter and tighter, or we become more and more refined, it meets the requirements of everything that's less granular. So by way of example, if I'm collecting water level information for my water district, and I'm doing so quarterly because that's the level of resolution I need, things are not that dynamic. that meets my needs. But then if I have a regulatory program that comes in and says, well, we need it monthly or bi-weekly, then as long as that becomes the new standard that I'm monitoring to, everything else will be met or satisfied as long as we're consistent with the monitoring standards, if you will. And so what's happened is we've failed in many cases to standardize that monitoring. And so one monitoring may take place in one particular area and you know, not overlap or not coordinate with the other regulatory program or the other user's need. And so I struggle to say, well, there's this one size fits all when it comes to monitoring or data collection, because I really do think it's what types of information or decisions are you trying to drive towards, and what level of granularity is needed to do that. And so I think it is truly a case-by-case situation, but certainly would welcome to hear from the others if they have other experiences.
Liu?
Yeah, I get this question. How much the number of the stations or the wells or information is adequate or enough for the government or anyone to make decisions? And from my point of view, after the China National Groundwater Monitoring Project, we found that the over 20,000 stations is far from enough for the country to make a general decision. But for example, in Beijing, we have very high intensive number of the wells, like around 10 wells for 100 kilometers square. But generally in the whole country, it's just 1 per 100 gram squares. So here's the problem that in some very major plants with a lot of people, a lot of action, a lot of industries, there's more than, I think, 20 or 30 per 100 kilometers is enough, or maybe enough for the government to make decisions if it can get the groundwater level on day basis or month or hour basis, and groundwater chemical conditions on month basis or half a year basis. So the number of the stations in China is not enough by now, but we are trying to build the phase 2 project in the next 5 to 10 years to make better decisions for the government. That's all.
And Jift?
Thank you very much for that question. In Malawi, we collect monitoring data in 2 ways. We have loggers, which collect data every 15 minutes. And then we also have manual data collection by our gauge readers or staff at the water development offices who collect it once per week. And we have data that is the data that we have been using. But we have been able to make decisions. We have been able to look at how we can use the data. So the issue of how much data is required is a bit tricky for us with the amount of resources that we have. Because with us, it means we have to think about how to collect that too much data that might be required. And we might also be required to look at how we are going to analyze that data that we have collected. If we need too much, if we have so much, then we need all the other resources, for example, computers, softwares, like maybe big data analytics, softwares, and all the others. So, and also we have to think of how to store that data. It's fortunate that now we have data on M-Water app, but in the past, as you saw from my presentation, we were using those cards. How many cards are you going to have? So to some extent, I feel like we should have enough data. About enough, I cannot explain, but let us talk of data that responds to the questions that I have at hand. And then That data must be accurate to be able to serve the purpose, must be validated to be true, and then it should be reliable as well as relevant. We have collected enough data, for example, when we go for drilling or we go for doing maybe a geophysical survey, we have hydrogeological and water quality map, which guide us in terms of where to go and drill and what to expect. We have hydrogeological maps, which explain the area, the thickness, or maybe the type of maybe aquifers in those areas, as well as maybe the geology in those areas. To some extent, that is enough. With the geophysical survey practice itself, we get results that we can mix up with all the little bit of data that we have and make decisions. That is somehow how far we have been going. But then with now, as we are considering integrated water resources management, then indeed we need more data. But with integrated resources management, we need more participants. This one will bring the data they have, this one will bring the data they have, and together we can make a decision, not in separate entities whereby all the water people are here, then maybe, for example, groundwater is here making decisions, surface water is there making decisions, or water quality is there making decisions. That can create problems. But if we are together and then we bring in all those other professionals as called for in integrated water resources management, then we'll be better off. We can be able to make a decision to suit our size because we know the situation and people can be able to contribute whatever they have, and we can make those decisions other than maybe having too much data. And instead of making decisions, we'll be starting now looking for what models can we do and what analytics can we do, or maybe how can we store the data and all other things. Thank you very much.
Thank you. Anita.
Perfect. So we have two related questions in the Q&A box, which are reflecting on the fact that to date in this conversation that we've been having, we've been primarily talking about data in relation to water levels, water quality, and the knowledge of the groundwater system. And yet there's other knowledge of the groundwater system besides data knowledge. Gift was just talking about hydrogeologic maps. And then there's also social data and ecological data that's important in order to jointly make a decision. And so we're just wondering how the data you've been collected fits hand in hand with other data that is necessary, and if there's other gaps in data that all of you are trying to collect, particularly social or ecological data, that could fit with your data sets to help better inform data management.
So I'll jump in again. The Sustainable Groundwater Management Act, which I've referred to, kind of changed how we manage water and data in California, to the point where, as water districts, we became responsible for the first time ever of evaluating the impacts of groundwater pumping on shallow wells that may be serving disadvantaged communities or economically disadvantaged communities. And so we have to now manage our groundwater basin in a way that's protective of certain users and uses, to and including the environment. And so, what, for example, we have to manage water to prevent water tables from dropping to the point where not only are wells impacted, whether it's below the screened interval or maybe into a zone that has high concentrations of arsenic, but we also have to evaluate the impact of water tables on what we call water dependent ecosystems. And so, for example, we don't want to create losing streams in areas where the habitat may be affected because we've created pumping depressions and dewatered that shallow zone that the environment was previously dependent upon. And so a lot of this information is being used to inform how we manage the resource, both internally within the water districts, but also through this regulatory process. So excellent question.
Shift.
Could you please come again with the question?
The question was, what other data and information needs to go hand in hand with the MWater data set that you've been collecting to help inform water management decisions? You've talked a little bit about hydrogeologic mapping, and you've talked about knowing which communities are nearby, but what other social ecological information is needed to help complement the data that you've collected on water points?
the M-Water app has plenty of information to the extent that I might say that we are not using everything that is there because we have just started. So we are focused mostly on the functionality. So there's functionality data in there. There is also water on lithology and geology, but we also would wish to have information in terms of population. How many people are in the area around this water point? M-Water can tell us maybe there is this water point and it is close to this school and that health center or hospital and this community. But in terms of numbers, in terms of populations, it is not there. There is also an issue with the data that we have. We have segregated it to the point of traditional authority, who is responsible for a bigger area. But we want it to go together with how the districts make their plannings. They do their planning based on a group village headman. The group village headman has a number of village headmen under him, but the group village headman is the one who we call it the area development committee, the one committee that makes the plans for development in an area. So we want to bring the data to that level so that whenever people are planning, they have everything other than maybe getting some more data from somewhere else. So there is population data that is required, but we can have that data from other departments. For example, the National Statistical Office, they can provide the data, and the survey department can provide the maps, maybe to share with them, maybe this is the area, so that we can have an area and we know all the aspects, for example, physical features in those areas, land use planning, or maybe land use in that area, type of activities that people are doing in that area, maybe the settlements, where they are and how they are, and all those things. So we are kind of like, since as we started from 2012 to 2019 up, now we are doing the updates. We'll continue to do updates, and then we are also in the process of adding in, depending on what people want. For example, we started with water, with WASH, and then sanitation was an element, and then the Ministry of Health needs some data that they also want to bring in M-Water. So it will be like improving it until when we are ready, sort of maybe to make all the things in the same. Thank you.
Well, we're quickly approaching the end of our time allotment, and I would like to ask each one of the three presenters to give me a 1-minute answer about what you think are the most important lessons learned in the first 30 seconds, and what is the biggest challenge you're going to face in the next coming years. So we'll start maybe with Jift. You have 30 seconds for each one of those to summarize, and then we'll be handing back over after all three of you to Anita. So Jift first.
Thank you very much. We have learned a lot in terms of water resources in the country, especially on how we are using it. Now we know the numbers, now we know the uses that the water is being put to and how it is being used. For example, we have a borehole that we supplied, maybe we drilled a borehole to supply water to the people. People were using the water, they would draw water, take it to homes, but then there was another part of the water that was being wasted. And now after sitting down, looking at all those things, we have decided to use the same water that is being maybe for cleaning the buckets and other things for permaculture. So we have a garden close to the water point. And then in terms of O&M, we have organization of maybe the water point committee, whereby the committee maybe at a water point knows how to raise funds and do all those other things. But sometimes they cannot be able to contribute to access water. Maybe, for example, they do not have enough funds or maybe money as a village, and maybe how to collect the money. So the permaculture garden is assisting. In terms of how to go forward, we are looking forward to improve how we collect the data, correct all the mistakes, as well as move forward in the same direction, because it is good. Thank you.
Okay, thank you. Liu.
Yeah. To summarize and to answer a question for my audience, I would say the most lesson tonight to me is we have finished the project, the construction, but we shall open the data to the authorities, not only the authorities, but the publics and to the world. and we shall open our monitoring indices, and not just water level and the chemicals. We shall open to the energy, or even biological researches, and to make a lot of use it, not just something hard, something cold in the field, but very, very useful information for more people to use. Thank you.
Eric is the final summary.
Thank you. So I think what I've learned is how much data actually is out there and available to the different water districts. It's just the challenge, which I guess is the corollary, is getting that data in a platform that is readily accessible to all of those who would like to have it. And I again use the vision of that Indiana Jones warehouse where public agencies have just filed something away, never to be seen again. I frankly have been shocked that there is as much data as there is. It's just getting it into a system that gives people access to it so they can start making those informed decisions.
And as an academic for your utopia, we should be making sure that every piece of data we have is published and available for everyone. So I'll pass over to Anita for some final summaries.
Terrific, great. Well, first I want to thank all three of our speakers. They provided us with lots of insightful information. And I think that the comparison and the contrast between the three different regions with similar problems in terms of having access to knowledge and having the data available, and yet very differing approaches that are context specific and are addressing the specific needs within a given location. I think that we have much that we can learn, and that there will be elements from each of the three that could be drawn from for any situation around the world. So again, thank you to all of our speakers. I'd also like to let you all know that we will be continuing the Groundwater Success Stories webinar series. And so stay tuned for our next series in the seminar series, which will be in November, and we'll be looking at multi approaches, where we are looking at large-scale systems that are combining differing approaches to managing groundwater, so it's not a singular approach but a multiple. And then coming in the new year, we'll have a seminar on where there are examples of successes in the use of incentives to reduce groundwater pumping. And with that, I'll turn it back over to the IWRA Executive Office.
Well, thank you so much for that. I really want to thank everyone on our panel for such a great webinar. So thank you to Dr. Kun Liu, Vice Director, Department of Water Quality Analysis and Evaluation at the China Institute of Geo-Environmental Monitoring, the China Geological Survey in China, Eric Everett, the CEO of Homer LLC and a board member of the California Water Data Consortium in California, and Jeffwanagwa, the coordinator of the Ministerial Task Force, Ministry of Agriculture, Irrigation and Water Development in Malawi. And of course, such thanks to our moderators, Anita Milman and Robert Kalin. Thanks everyone for really your participation. Like I say, we couldn't do this without you. So I really hope that everyone, both in the panel and in the audience, found all the insights provided during this conversation, both in the presentations, and I really appreciated all the conversation and discussion we had in the time after. We were able to have a nice, real debate and conversation. I thought that really drew out a lot of texture and depth in our presentations. So I really appreciate that. And I hope that this is really going to help drive everyone, both the creativity in your work, but as well as be able to advance some new ideas. So I hope everyone takes something away from this event today. So if the presentations left you interested in learning more, please feel free to go to our LinkedIn webpage and follow us